Good day everyone, I am Rochelle Esmerante from BSED Math 2A. In this video, I will discuss the project given to us. We are given a problem, and from that problem, we are tasked to generate a solid of revolution using GeoGebra or Wolfram Alpha. After that, we need to look for a real-life object that is in similar form or figure with the solid of revolution generated. And lastly is to solve for its volume. Let me start with the real-life object that we choose that is in similar form with the solid of revolution generated. This object is a framed radiance. So what is a framed radiance? A framed radiance refers to a lump who typically has a rounded or flared shape with a hollow center. So this figure connects to the assigned problem to us, as both involves finding the volume of a rotated shape. Given a problem in finding the volume of a solid of revolution, we need to remember on when to use the three methods: the disk, the washer, or the shell method, for us to know on what will be the best method to use to find the volume of a solid of revolution. So disk and washer is a similar concept in finding the volume of a solid of revolution. The only difference is that the washer has a hole in it, so we can think of it as a disk with a hole. So we can use disk and washer if the axis of revolution is the boundary of the plane region and the cross sections are taken perpendicular to the axis of revolution. So we can use the two methods, the disk and washer, if the rectangular elements are perpendicular to the axis of revolution. On the other hand, we can use the shell method if the cross sections of the solid are taken parallel to the axis of revolution. So we can use this method if the rectangular elements appeared to be parallel to the axis of revolution. So take note that we will use disk and washer method if the rectangular elements are perpendicular to the axis of revolution, while we will use the shell method if the rectangular elements appeared to be parallel to the axis of revolution. So the problem is to find the volume of the solid generated when the region bounded by the curve y is equal to 2x squared minus 2x cubed, the x-axis, and the vertical lines x is equal to 0 and x is equal to 1 is revolved about the y-axis. So to find the volume and to know what will be the best method to use, let's have an illustration. So the illustration looks like this one. So in the figure, we can see a red rectangular element and the yellow vertical line, which is our axis of revolution. So based on the illustration, we will not use the disk or washer because the rectangular element appeared to be not perpendicular to the axis of revolution but is parallel to the axis of revolution. So with that, we will use the shell method. And also, shell method allows us to integrate with respect to x and use the function as originally given. So with this, the shell method is not that complicated to use. So next, we have here the figure and its labels. So in the figure, we can see the green curve, which is y is equal to 2x squared minus 2x cubed. We also have the yellow horizontal line or the x-axis, which means that in every x, y is equal to 0, and the red vertical line, which is x is equal to 1, and the other vertical line that is in color blue is x is equal to 0, which is also our axis of revolution, and the shaded region is in color violet. So if we rotate it around the y-axis, we will generate this figure. So in the next figure, we can see the height, the radius, and the thickness of the figure. So the height is simply the given function, which is y is equal to 2x squared minus 2x cubed, and the radius is the distance between the axis of revolution to the shell, which is x, and the d of x is the thickness, or how thin or thick the shell is. And we also have here the a, which is located at the center with x is equal to 0, and the b, which is located at x is equal to 1. By the way, we have here the sides, the top, and the bottom view. So as you can see in the picture, we have here the solid of revolution on different views: the top view, the left side view, the right side view, and the bottom view. So now we have here the formula of shell method, which is volume is equal to the integral from a to b of a of x dx. So our a of x is simply equal to 2 pi times r times h. So now we will find a and b. So based on the figure earlier, the a is located at the center, which is x is equal to 0, and our b is in x is equal to 1. So also the integral sign means that we will add all the surface area of the shell that will give us the volume of the 3D object. So we will need to find the height, the radius, and the thickness of the shell now. So our radius is simply the distance between the axis of revolution to the shell, which is x, and the height is the function given, which is y is equal to 2x squared minus 2x cubed, and the dx is the thickness, or how thick or thin the shell is. Now here is the solution for the problem. So first, we will write all the given. So the given are the curve y is equal to 2x squared minus 2x cubed, or the region is bounded by the curve y is equal to 2x squared minus 2x cubed, the x-axis, or the y is equal to 0, the vertical lines x is equal to 0 and x is equal to 1, and the axis of revolution, which is the y-axis. So now we will write again the formula for the volume, which is volume is equal to the integral from a to b of a of x dx, where a of x is equal to the 2 pi times r times h, and based on the given earlier, the radius is equal to x, and our height is the function 2x squared minus 2x cubed. Now we can substitute all the given into our formula. So since 2 pi is a constant, we can move it outside the integral sign, and it will become 2 pi, the integral from 0 to 1 of x times 2x squared minus 2x cubed dx, and x times 2x squared minus 2x cubed is equal to 2x cubed minus 2x raised to 4. So based on the power rule of antiderivative, as long as the exponent is not equal to -1, we can use the rule u raised to n is equal to u raised to n plus 1 over n plus 1. So by applying this rule to 2x raised to 3 minus 2x raised to 4, it will become 2 times x raised to 4 over 4 minus 2 times x raised to 5 over 5. So by simplifying, we can get 2 pi times 1/2 x raised to 4 minus 2/5 x raised to 5, which is evaluated from 0 to 1. Now we can substitute 1 and 0 into our equation. So it will become 2 pi times 1/2 1 raised to 4 minus 2/5 times 1 raised to 5 minus 0. It is 0 since 1/2 times 0 and 2/5 times 0 is equal to 0. So now we can simplify 1/2 minus 2/5 and it will result for us to have 5 minus 4 over 10. So 5 minus 4 over 10 is equal to 1 over 10. And if we multiply it to 2 pi, we will get 2 pi over 10, which is also equal to pi over 5 and is approximately around 0.628 cubic units. So therefore, the volume of the solid generated revolving about the region bounded by the curve y is equal to 2x squared minus 2x cubed, the x-axis and the vertical lines x is equal to 1 and x is equal to 0, about the y-axis is approximately 0.628 cubic units. By understanding and applying this method, we can determine the amount of materials needed to create the lamp hood and appreciate how mathematical models are used to create practical and functional objects. This method allows us to calculate the precise calculation through integration. Its application in real-life context, just like in engineering, demonstrates the relevance of calculus in solving real-world problems. So that would be all. Thank you.